Hello, everybody, and I hope you're enjoying the FIT conference so far. My name is Adam Myers, and I'm head of cyber sales here at CyberLab. And with me today, I have Rick Ferguson from Forescout. The topic of today's session is the threats to our hyper-converged world. And Rick will be talking us through the evolution of threats to operation technology and how connected devices and even medical technology have become more attractive to threat actors. So yeah, really insightful session, and I'll hand you over to Rick now to walk us through that.
Yes, we're going to talk about who is targeting your OT environments, whether that's operational technology, ICS, medical, even IoT, building management systems, all of these different devices, and why, what they're hoping to do, and hopefully then we'll have some lessons about what we can take away from that as security practitioners. So the reason why I think this is an important topic is bearing in mind this prediction from Gartner, and it's a widely held view across the industry, that in the not too distant future, the vast majority of organizations will have converged their security across both the traditional enterprise function of the business, but also the operational technology and ICS side of the business as well. At the moment, that's not the case, and really that's kind of part of the challenge. There are many facets to the challenge. Here are, for me, what are the most pressing ones. A lot of OT is insecure by design, and by that I mean these are very often things that were never designed to be connected. Some of them even can be relatively old infrastructure. A lot of what we consider to be security best practices in our enterprise technology software, for example, such as authentication mechanisms, for example, encryption schemes and implementations. A lot of those best practices are simply not followed in OT, hence the term insecure by design. And what we're also seeing is an increased focus on potential vulnerabilities and research into vulnerabilities in operational technology year on year. It's true to say that the number of vulnerabilities in general that are published every year always increases, but the rate of increase in vulnerabilities in OT is certainly greater than the rate of increase most years in traditional enterprise technology. So vulnerabilities are there to be taken advantage of. But things like, for example, you think patching is bad in enterprise infrastructure, have a look at patching in OT. There's an aphorism in OT, for example, never touch a running system. So it's a very complex environment to carry out those IT best practices in. Add to that the fact that security teams are almost never integrated across those functions. So the security team looking after the enterprise side of the business is rarely the same as, if there even is, the security team looking after the operational side of the business. And even if you do have one, it's very difficult for them to have any visibility of the assets connected to the network. They're not speaking protocols that are widely understood or widely parsed. So even if you took a traditional intrusion prevention device, for example, and hooked it up to an OT network, it'll probably tell you that everything's okay, but mostly because it doesn't understand anything that it's seeing on the wire. So in numerical terms, if we think about malware attacks on OT devices and in OT environments, you're probably used to the kind of numbers that we talk about for enterprise malware, which is in the millions in terms of new malware samples, new unique samples, new malicious domains, new malicious IP addresses, phishing emails. The volume is incredible. It's not true to say that the same volume is applicable to an OT environment. In fact, I started to put together for this presentation a timeline of OT attacks to kind of pull together, well, how many different kinds of malware have we seen that have been specifically written to target OT environments? And actually, the number is incredibly low. Of course, we've all heard of Stuxnet. Stuxnet was really the very first malware to cause what we call cyber physical damage that was targeted at the Natanz nuclear enrichment facility in Iran, causing centrifuges to spin faster than they should and to crack, to delay progress in that establishment. That was only back in 2010. And then we've seen this growing timeline. Havex was a remote access Trojan that was attributed eventually to the Energetic Bear APT, which is part of the FSB in Russia. Havex was really a reconnaissance Trojan. It was an information collecting Trojan, but it had modules that were specifically designed to parse and understand ICS industrial protocols. There was another incident, the steel mill in Germany, that you can see the dates on everyone. The steel mill in Germany, that was not attributed to malware, but it was a very interesting scenario, I guess, unless you were the steel mill owner, that looked like human interaction with the industrial controls on that facility, which led to them not being able to shut it down correctly, and led, in fact, to the loss of one of the furnaces because it basically melted. So that was a human interaction attack. And then we saw a lot of Russian interest post the annexation of Crimea and in the ongoing war in Ukraine. Started out with Black Energy 3 and followed up with Indestroyer starting in 2014, which was aimed at taking out significant parts of the electricity grid. And each one of those attacks, both attributed to the Russian GRU, by the way, the second one iterated on the first one, added capabilities, added technology, added stealth, automated functions, for example. So those were kind of the first 5, but of course it didn't stop there. But the timeline isn't incredibly long. We saw that the next thing that happened after the second attack on the electricity grid in Ukraine was, for me, a super interesting one called Triton. Triton attacked what we call safety instrumented systems. Now, OT devices, obviously they are kinetic, right? They have effects in the real world. So they have backup safety systems that are there really designed to detect if something is going wrong, dangerously wrong. They're there to kind of step in and bring the system to a safe shutdown stage. Knowing that something's going wrong, they intervene and shut the system down to a known good state. Triton was the first malware that attacked directly those safety instrumented systems so that they could be taken out of commission. And then if the device itself was attacked, the bad thing would happen rather than have the instrumented systems step in and bring it to a close. I think you can begin to see a pattern in the attribution on each of these attacks. Certainly the vast majority that we know of anyway, interest in and deployment of OT-specific malware has been the Russian state, FSB, GRU. ECANS stood out in that it wasn't that. ECANS, as far as I know to date, is the only ransomware that was ever deployed that had a kill list for processes, which is not uncommon, but this kill list for processes included ICS-specific processes. So this ransomware was designed to be deployed to and to render inoperative industrial control systems by looking for those processes and killing them before the encryption happened. As far as I know, that's not happened since, but certainly it means the capability exists. It's out there. We saw Indestroyer 2 deployed at the very beginning of the full-scale invasion of Ukraine, and then a couple of other tools were discovered before they could really do any damage. In Controller being one of them, and Cosmic Energy looks more like it might have been a red teaming tool that was again used by organizations within the Russian state. That's it. That's the full list of malware and attacks that have been specifically targeted at OT institutions. But of course, that's not the fullness of the story. The consequences of war have been huge. Of course, we've seen cyber attacks. We saw wipers. We see disinformation attacks. We see denial of services attacks. We see run-of-the-mill cyber criminals using tragic news like the invasion of Ukraine or the events unfolding today in Israel to try fake fundraising schemes to make money. These things are all expected, right? That happens. Some of the new kids on the block, though, we've seen, for example, hacktivist ransomware. It's not really ransomware, but it's ransomware repurposed. There was a group of cyber partisans, they were called, in Belarus, who took ransomware, they neutered it so that it wasn't really there for actually raising any cash, but they used it against the Belarusian railway to bring all of their systems to a halt, to make it impossible to transport men and material across the country to take part in the war in Ukraine. So certainly we're seeing old attacks being repurposed. We're also seeing web defacement. Again, a standard tactic of hacktivists. What you can see on the screen on the right-hand side right now is a portal for selling cinema tickets in Russian in Russia. All of the thumbnails for each of the films have been replaced, as you can see for yourself, with messages about Russia being a terrorist state, Putin being a war criminal. And again, these kind of web defacement are standard hacktivist attacks that we would fully expect to see in this kind of scenario. But here's the bit that worries me, the stuff on the left-hand side of the screen. These are hacktivist attacks where they were recruiting volunteers to be given instructions to take part in hacktivist attacks. And you can see, even if you don't understand the Russian, you can see the kinds of systems that are being targeted here. These are electricity generation, manufacturing. These are operational technology and ICS. We see more than 100 groups conducting active cyber attacks since the beginning of the invasion of Ukraine. And we see other groups protesting actions. This is even prior to the Hamas terrorist attack on Ukraine recently, targeting other nations like Iran, like Israel, like Nicaragua, around the globe. So these have become standard tactics, using standard reconnaissance tools, using vulnerabilities, using misconfiguration, using distributed denial of service attacks, specifically against OT infrastructure. There is a consistent level of expertise where people are actually looking for the kinds of devices that we see exposed online. You can see how many of which kinds of devices we're seeing in the scans that we carry out, but also we're seeing ability. So not only are these devices being discovered, but they're being actively targeted by attackers. We see people, for example, targeting exploits, for example, like serial to IP converters in specific OT equipment. So the knowledge of these devices and the knowledge of the vulnerability and the ability to exploit it is out there. And we see exploits over common protocols like HTTP for devices like building automation, programmable logic controllers. And this pertains not just to operational technology, but also, of course, to critical national infrastructure. And really, the greatest problem with that is that the reality in a security operations center today, and this is before we talk about converging these functions to the much greater degree that Gartner is predicting, is drowning in an incredible volume of alerts. In fact, according to a relatively recent study by Palo Alto Networks, the average SOC team is dealing with about 11,000 alerts in every 24-hour period and keeping track of about 7 different threat intelligence feeds, all at the same time. And there's just no way that the typical security operations center is staffed to the levels required to be able to deal with this volume of information. If data is the new oil, which is kind of a truism, then algorithms are the new refineries. It's about having the required expertise to take that data and turn it into something useful. The expertise that Forescout has in device recognition, network access control, threat detection and response, network segmentation, but overall for me, it's the power of the visibility really puts us in a powerful and unique position. We're not an OT company, we're not a NAC company, we're not an XDR company. We are all of those things, but we're more than the sum of all of those things. Forescout really is a cybersecurity provider for everything. So here's my 5 principles for effective IT security. It must be built on a foundation of complete visibility. If you can't see it, you can't secure it. Visibility is the underlying foundation of everything we do in security. Your risk assessment must be continuous. You can't rely on a snapshot mentality. You have to move beyond, I've done a pen test and I've done my compliance, I'm good for the next 12 months. You need dynamic, ongoing, continual risk assessment of your environment. You need to be able to, that risk assessment has to allow you to minimize your attack surface on an ongoing basis and allow you to ensure that the environment you have built remains defensible, that you're not creating vulnerable silos, that you're not unnecessarily exposing devices to the internet, that you're not failing to segment a network internally to deny an attacker the ability to move laterally within your environment. And of course, manage, automate everything you can, monitor, respond, and critically archive, because you need to be able to go back in the event of an attack and find patient 0 and find every other affected asset so that you can respond effectively. Thank you very much for listening. And I guess I'll hand back.
Wow, what a session. I could listen to you for hours, Rick. I think just listening to the development and those 5 tips were fantastic. But if you want any more information and work with the team at Forescout, And equally at CyberLab, just reach out and we can follow up this session with more information. So thank you very much, Rick, and enjoy the rest of the conference.